we've drawn our ducts and canals, we want to also place some vents and terminals. And then later on, we will also be placing some different shapes of terminals. So now I want to explain to you the way of placing some terminals and some things about sealing vents into a blank file or actually an unused template. And then we will also work on a project so that you can see that entire process being applied into a project. First, let's become familiar with the types of terminals, and then we will head to the project. I've opened a mechanical template, so now I go to the Systems tab, and then the Duct command, and we will be starting by drawing a canal and using ducts. For the fitting type, we will be selecting radius, elbows, tabs, with the system type supply air as it is as default. For the width, we're going to be entering 1000 and height 800, and as for the elevation, we're going to keep it 2750. The first click, and now the second click, and then escape. So now we've drawn one piece of duct, and now we want to place some terminals right next to it. To do that, we're going to go to the Systems tab, and then click on the Air Terminal command, and then in the Properties window, we can see the family for the loaded terminals. Now, here in this very template, we have one exhaust grill and return diffuser, as well as supply diffuser, and we also have two other types of supply grills as well, one of which has a curved face and the other has a flat rectangular face. So right now we will be using this supply diffuser, and you can see in the preview what it looks like. You can see it has a square shape, and we also have its dimensions 800 by 800 face, meaning that the surface of this terminal is 60 centimeters by 60 centimeters, and its connection is 300 by 300. The dimension of the duct that's going to be connected to it is 300 or 30 centimeters. So when we select it, here in the Properties window, actually let me widen this window. In the Elevation from Level section, we can decide what the elevation of this terminal from the level, which level, the one that you see right above it. So for that, we will be, for example, we will have it 2000. Which makes it 2 meters from level 1. Now we're going to go to the drawing area and click on a blank surface to place that terminal. If we want to have a better view on things, we can go to the Quick Access toolbar, click on Section, and now the first click and then the second click, and overall create a section. Now we're going to go to the section box and right click and go to View, so that we will be able to see the section isolated. Now I'm going to drag this a little bit wider and set its detail level on Fine, and if we want to have an even better view on things, we can select Shaded. Alright, now we can see the placements of the duct and the terminal compared to one another. And now we want to draw a junction and connect these two. We have multiple ways of doing that, and I will be explaining to you each and every one of them. So now, if we want to see the section and the plan at the same time, we're going to go to the View tab and click on Tile Views. Let's also minimize the Properties window, as well as this Project Browser window. Now on the left we have the section, and on the right side we have the plan itself. While we are in the plan, we're going to go to the Systems tab and activate the Duct command, and then for the width we're going to enter 300 and 300 for the height. If you recall, this was the connection of the terminal. Alright, now here in the area, you see when we move the mouse along the axis line of the duct, at a certain point you might notice that your pointer changes. This happens to indicate the center of the terminal compared to the duct. And as you can see, it's also shown by dash lines. So you see I'm going to move, and then for a split second, our mouse pointer disappears right along the terminal, and we can see the line leading to the center of the terminal. Now, if we start moving from the edge of this duct, we would still have the disappearance of the pointer. Also, if you noticed, you can see that the terminal becomes highlighted, but we no longer have any central dash lines. Let's do it again. This terminal is black, and now I'm going to move the mouse along the outer line of the duct, and then suddenly the pointer disappears and highlights the terminal. This is actually an indicator for being right along the center of that terminal. So now first click and the second click right on the axis of the terminal. Now look in the section, the first click was here and the other was right over here. So Revit itself just applied the proper connection for us. One straight duct and an elbow, and then another direct duct, and then connected it to the terminal. And now if you pay attention to the plan, you can see that the terminal that's been connected to the duct, its color changed to the color of the duct. Let's undo so you can see it again. As you can see, it's black. So now click and click. The terminal that connects to a duct, its color changes to the color of that duct. As you can see, it turned blue. We're going to press escape. Let's go check it in 3D as well. We're going to go to the quick access toolbar and click on default 3D view. Alright, now let's move the area using shift key and scroll. And to have a better look, we can select shaded. Alright, now you can see the tab and the piece of duct, elbow, and then another piece of duct, and this way they've been connected to one another. Alright, now again in the plan, we're going to go to the Systems tab and click on Air Terminal, but this time give it a higher elevation. For example, 2500. We're going to come here and click on a blank space and escape. Now let's move the section a little bit. We're going to move it to the side, and we'll even make it a little smaller so that we can only see this terminal. Alright, now you can see the elevation of this terminal compared to the duct. Let's go see how we can connect it now. While we are in the floor plan, we activate the duct command, this time through the shortcut DT, and with the same dimensions, 300 by 300, the first click, and then the second one. So now, elevation-wise, we can clearly see what we have drawn. But we also got an error. Let's go read it together so we can see what it says. There was not enough room to place the required fittings. You can see that it says we didn't have enough room or enough space to place the required fitting, the one that we need, the one that's proper and appropriate for connecting these two together. Do you remember in the previous one, it gave us an elbow and then made it happen? This time it says you don't even have enough room to place an elbow. So what do you want to do now? These things are normal and possible to happen. So I'm going to cancel this, and again, click, and then somewhere near the terminal, the second click. And then we press escape. So now we've drawn one single direct duct. And now we're going to go to the Systems tab, and then click on Flex Duct command. This is a tool for drawing flexible ducts in the project. Alright, now in the Properties window, we can either use Flex Rectangular or we can use the Flexible Round, which is circular. And you should always make sure that the system type of your terminal needs to be the same thing as the system type of your duct. And in the options bar, you can enter your diameter or middle elevation. So now, starting from the end of this duct, we're going to click, and right until the axis of the terminal, click again. Then we press escape. So you see it just connected a flexible duct for us, and you can tell by its name that it is flexible. And for needed occasions like this one, it could turn to some sides and then connect to the terminal. So in case you can't use hard ducts, you can also go ahead and use the flexible ducts that you have. Let's go check it in 3D. Look over here. As you can see, we have the tab, the direct duct, And you know our starting duct was rectangular. So when it was trying to connect to a round one, here in the middle it gave us a rectangular to round transition. If you recall, we've talked about that before. Now, to finish the process, this round duct was trying to connect to this square terminal, so it used a transition to connect these two. It was a round to rectangular, or round to square transition. So, as you can see, it applies the needed transition automatically. Again, we're going to go to the Plan and Systems tab, Air Terminal, and in that same 2000 elevation, we're going to place one more terminal. So click and escape. Let's also move this section a little bit to the side right here. This time we're going to go to the Systems tab and then the Duct command. Then we're going to select a round duct. Round duct taps with system type supply air and diameter 300. So click and click again. And now we press escape. Let's go see in 3D. So now we know that we can have a rectangular duct and get a round junction from it and connect it to the terminal. But again, pay attention that because our duct was round and the terminal was square, a rectangular to round transition will also be applied. Again, let's go to the plan and see another one. We go to Systems tab, Air Terminal, Elevation 2000, and click. And then escape. Let's move that same section right onto here. And now we go to the Systems tab, and we go right to the Flex Duct command. We want to draw a flexible duct. The system type is the same as the ducts, and we will give it a diameter. So now click and click, and then the escape key. Let's go in 3D. We can also draw a flexible duct and make it the entire connection. As in, we don't need to draw a direct duct first, and then go ahead and draw a flexible duct. So now, if you look here on this flexible, this circle, and this circle, as well as this one, these are actually the circles through which we can change the shape of our flexible duct. It's the same thing in section as well. Can you see those circles right here? I'm going to click on these circles and drag them a little bit. And again, I'm going to do that same thing to the second one. And I'm going to take this one and drag it a little bit to this side. So you see we can change the way that this flexible duct goes. That's why it's named flexible. It can take different shapes. But as you can see, the circle moved a little bit up to here. So I'm just going to move it like this. Now you've probably seen these types of flexible ducts, for example, in the stove hoods for the kitchens. They are circular, their colors are usually white, and they have a soft surface. So these flexible ducts which we are drawing are something like those. I'm only giving you these examples so that you can have an image of it. So back in the plan, you see this one which was connected with a direct duct. We're going to click on the duct or the terminal. There's no difference. I just clicked on the terminal. If I use the right and left arrows from the keyboard, it moves to the side, and both the terminal and its connection will start moving to the right or left. This is because they are directly connected to one another. But this one, which is connected using a flexible, let's select it real quick. Do you see when we try to move it to the left, it's the flexible one which extends. Actually, let me move and drag this 3D to the side here. There we go. You see, there it is. If we move this terminal in the plan, it kind of looks like that the flexible duct extends and widens. We can also move it to the front and we can see the same thing again. Also to the left. But if we select the straight duct and move it to the right or left, you can see that the flexible extends again. I just want you to take in how this flexible duct works. It's completely flexible, it can take different shapes and moves in different ways. Alright, now in the second type, we're gonna go to the Systems tab and Air Terminal and place another terminal, then again in the Systems tab and the Duct command. There's no difference whether you select round or rectangular, so we're gonna connect the duct to the terminal and click in Escape. So now we see that a straight duct has been created, but then at some point I remember that I need to draw a flexible duct here. But the problem is that I've already drawn a connection. So what should we do? Do we have to delete this and draw a flexible instead? Or is there another thing we can do? There's no need to remove this. There's a certain command to fix it. You can go to the Systems tab and find the command that says Convert to Flex Duct. This one turns our duct into a flexible one. So once we click on it, first we have to select the type of our flexible duct and then determine the maximum length that we want this flexible duct to have, and then go and click on the terminal. Did you see what just happened? Let's escape and Ctrl-Z to undo it. Let's do it again. We go to the Convert to Flex Duct, determine the type of our flex duct and the maximum length that we want, and then once we click on the terminal, the duct converts to flexible. Now, depending on the type of our flexible, which the first duct was rectangular, it gave us a rectangular to round transition as well. Let's try another one. We're going to go to the Systems tab and the Air Terminal command, and we place another terminal here. We just want to try another method to connect the duct to this terminal. So first we're going to click on the terminal to select it, and up here in the ribbon we see an option called Connect Into. You can probably figure out what it means. So we're going to click. Now what do we want to connect this terminal into? We want this duct. Do you see that? So without having to select the duct command, we were able to connect this terminal to the duct. Let's Ctrl-Z and do it again. First we click on the terminal and connect it into this duct. And there we go. So how does it know which types to choose to connect these two? It takes those settings from the fitting types and properties that this duct has. Let's Ctrl-Z and undo it real quick. We're going to click on the main duct and change its fitting type to mitered elbows T's. So we've just changed its fitting type. This will be applied for the future ones. So we're going to click on the terminal and then connect it into this duct. You can see the mitered elbow, and you remember it was mitered T. So here for the connection, it applied a T, and because the size of the duct was different from the connection, a transition was also applied onto here. So it takes its properties and features from the original main duct. I'm going to press Ctrl-Z again and select the duct and make its fitting radius elbows tabs. And now we select the terminal and connect it into this duct. This connect into method really helps out in such circumstances. For example, when we have a terminal and it needs to connect from above, and when our duct is placed like so, and connects them both using an L shape. When we go further for another terminal type, to see whether or not we will have a good result like this one. Now let's head to the next one. Because our duct has run out of room, I'm going to show you the rest of it down here. So again, we're going to go to the Systems tab and click on Air Terminal. So now our terminal has its own specific sizes, 60 by 60 for its face, and the size of its connection is 30 by 30. Now, what can we do in case we have a duct with different sizes than this in the project? The thing is, we can create a new size for that. Now, how can we do that? While we've selected the terminal, we're going to go and click on Edit Type. And then a window will pop up in which we have a dimensions section including all the dimensions and sizes. Remember, we're not going to change that. We're just going to get a duplicate. And we have to enter a new name, right? So I'm going to delete this too from here. And we're going to enter the name according to the sizes and the design that we need to put in the project. For example, I'm going to enter 800 by 800 face and 500 by 500 connection. So there goes its name. And now we have to go adjust its sizes from the dimension section. You can see we have duct width, duct height, diffuser width, and diffuser height. Now let's picture it ourselves for a second. The parts where it says duct width and duct height are related for the connection of our duct. So now we know that we have to enter 500 for these two. And as for the parts that have the word diffuser in them, they indicate the terminal itself. We have width and height for that. So now we can enter the sizes. Now, in case you couldn't figure out what these indicated or you had strange names, what you can do is that you can click on Preview, which shows you a preview of the terminal itself. And now on whichever one that you click, for example, duct width, do you see in the preview how it shows you the lines indicating that? So here, this preview that we can have is very similar to the default drawing area in the project. Here you can also change the views. We have from reference level, which is the bird's eye view on the section, or this 3D option that we have, which you can view it from top, and you can also rotate it. So you can check it in different views so you can see that this indicator right here, which one is it referring to? You see, duct width is referring to this part, which is right along the indicator lines. And the duct height is referring to this side. Diffuser width is the surface, and the diffuser height is this part. So if you remember, our duct width was 500. So we're going to enter this number. And if we click on the box below or anywhere, we just want to click somewhere besides the 500 so that it confirms it. So once we did that, the duct height also became 500. So this means that our duct width and duct height are the same numbers. You will see this later in the family space. But in the family space, it kind of looks like we have formulas which emphasize on the duct width and height being the same. So if we change one of them, the other one changes as well. It's the same thing for these as well. I'm going to enter 800 and the other changes to 800. So from now on, when we go to the properties window, we can see two types now. One is the 600, which was the default, and the other is 800, which we just added. So the 800 one is selected, and we're going to put its elevation 1500, and then we're going to click in a blank space, and then it will be placed. Now we're going to press Escape. There it is. Let me move it so you can see. There we go. So now to connect it, we can use any of these methods that we just talked about. We're going to activate the duct command and enter 500 for the sizes, and click, and then click. So now the connection has been applied using that method. So now we might want a whole different family. For example, that family's face is rectangular and its connection is also rectangular, but we want a family which has a round connection. So that, for example, in case we have a situation like this, where our duct was round and we wanted to connect it to this terminal, we wouldn't need a transition. We just want our connection to also be round. So now we have to load a new family, because in this case, that previous family won't do any good for us. We're going to go to the Insert tab and click on Load Family. So right now we are in the Imperial folder, But because we were working with metric, we're going to go back a folder and go into English. And then US. Now, where are our terminals? We have a folder called Mechanical. Then we go to MEP. Then we can find some items. There's a folder named Airside Components, which includes the items that are related to air. There's also another folder which we will talk about later. This one's called Waterside Components. It's the items that are needed for water. Things like pump, boiler, water softener, just the items needed in the generator rooms. Now, airside components are the ones for air. Things like terminals, fan coils, VRF, VAV, or even conditioners. So we're going to click and we can see the folders for all of them here. The one we're looking for is air terminal. So we're going to click and open and we can see all the types of terminals listed here. You remember our duct was supply, so we're going to go to the ones that have the name supply in them. These are all the supplies that we have. And the one that we've been using so far is this one. It's called supply diffuser. But now we want to use a supply diffuser which has a rectangular face, and the part for it, which is for the connection, we want that to be round. So right now we can find this. Supply diffuser, rectangular face, round neck. Neck is actually the connection part. The part which is for the connection, we also call that the neck. We can still find some other types as well. For example, a terminal with a round face. You can see here it says circular, round neck, and this one circular, rectangular neck. This means that the face of the duct is circular and round, but the connection rectangular. Or we can have a circular face and a round neck. But if you pay attention, you can see that at the end of both of them it says ceiling mounted, which I will explain to you what it means later on. Now, can you see the ones that say hosted or ceiling mounted? We will talk about all of these later on. But for now, you can just use this one, rectangular face, round neck. So select and open it, and then go to the Systems tab and click on Air Terminal. And if you see right here, a new terminal type called Supply Diffuser. If you pay attention, these are the ones that we already had. Supply Diffuser with 2 sizes. And this is the new inserted one, Supply Diffuser with other new sizes. For example, we're going to use this size, 600 by 600, which is its face, and its neck is 300. And now let's enter its elevation, which is 2000. We're going to go to the plan, click, and place it in a proper space. Then we press Escape. And now we're going to go to the Systems tab and activate the Duct command, but this time select a round duct with the diameter 300 and then click, and click again and Escape. Alright, so as you can see, our neck is round, and we've also drawn a circular duct, and because of that, Revit didn't see it necessary to apply a rectangular to round transition to make this connection happen. Now, another thing, our duct is supply, as well as the terminals which we have created. Now let's go do something. We have drawn a supply duct, so we're going to go to the Systems tab and Air Terminal. Then we're going to use the terminal type, this return one. You can see that on the surface it looks just like the previous terminal type. It only says that its type is return. Let's go see what will happen. 2000, we're going to click here and then Escape. Then we go to the Duct command and select the Radius Elbows Tabs type. The type is supply and dimensions 300 by 300. Now we're going to click and click. If you look in 3D, this connection happened, but we just got a warning down here. So let's go see what this warning says. As you can see, it's written, the element you are trying to connect to has a different system classification. So what it's trying to say is that these two items that we are trying to connect, each of them has its own different system classification or system type. The classification of one of them is supply, and the other one, which is the terminal, its type is return. So if it was necessary, they can connect, but it won't have a perfect shape. On the outside, if you see, nothing bad has happened, but the problems with the classification, we have a problem with their types. So later on, when we are trying to make some size measurements, we might face a problem. So if your duct is supply, you have to use a supply terminal. And if your duct was exhaust, you have to use exhaust terminal and use return terminal for return ducts. So this means that their types or their classifications all need to be the same. So in conclusion, I've just mentioned all of the possible types and ways of creating square terminals. Let's go select Tab Views and get a review on everything that we've just placed so far. In the first occasion, we created a terminal and connected it to the duct using a straight duct. In the second one, we used the flex duct command because their elevations were in a way that we couldn't use a straight duct. And as for the third one, we made this connection happen using a circular duct. And in the next one, we connected the terminal to the duct using a whole flexible duct. And for this one, we used the convert to flex duct command. And then for this one, we used the connect into command to connect them together. And then here we changed the size of the terminal itself, as well as its family. And for this one, we talked about what would happen in case the classification of the terminal and the duct are different from one another. We will also check all of these in the project as well. It also may differ that which types of these terminals we might use in each project. But again, we will also check them out later. Now let me tell you some other things. You see, we're going to go a little further down and then go to the Systems tab and Air Terminal. Let's go place an exhaust terminal. So click. Now let's put a return. Click. And let's also put a supply one. Click. We just want to see what they look like right next to each other. The supply terminal, as you can see, has two crossing lines in the middle, which indicate the diameter, and the arrows around it are towards the outside. They are the indicators for a supply terminal. Now in the next one, return, only one of the diameter lines have been included and the arrows are towards the inside. And as for the other one, which is exhaust, one of the diameters is complete, the others in half, and the arrows are towards the inside. So through knowing their appearances, you can also recognize which type these terminals are. So now we're going to try to do something. We're going to draw a vertical duct. We go to Systems tab and the Duct command, and then we enter the sizes 600 by 600. The type is supply with the elevation 4000, and then we're going to click Apply and Apply again. And now for the next one, which is return, we're going to change the elevation from 4000 to 0, and then apply, apply. And for the other one, exhaust, from the elevation 4000, we're going to enter it and click on Apply, Apply, and then Escape. I just wanted you to know that even if you draw straight ducts or riser ducts, this is what they're going to look like depending on their middle elevation. The one for supply looks like its terminal, as well as return, it looks like the one for itself. But for exhaust, it's a little bit different. It doesn't look like a terminal, it looks like a return. So make sure to keep this difference in mind. Let's go see in 3D. These are the ones that I meant. We have vertical ducts from the elevation 0 up to elevation 4000. Standard shape to them, so you can memorize them so that in case you ever see them in your project, you can immediately recognize which type they are. Now another thing we can point to is that we have arrows on 4 sides of this one. So this means that this is a 4-sided terminal. Now, if we select it, we can go to the Properties window and see we have 4 arrow options. We have up, right, left, and down. If we uncheck the up and down arrows, we will have a 2-sided terminal, and we will only see 2 arrows left. Or vice versa, if we remove right and left and keep up and down, the same thing applies. So even if your terminal type was 2-sided, you can adjust it using these arrows. And one more thing is that we also have an option called flow. It's the airflow. And by default here we have 235 liters per second, but depending on our plan, we can change that as well. For example, I'm going to put number 35 liters per second. We might also have the CFM unit in the plan. We can also change that if necessary. We've talked about editing units before. We go to the Manage tab and click on Project Units. Either that or you can use the UN shortcut. And then you're going to go to Discipline HVAC, and then in the Airflow section, you can change liter per second to CFM. CFM is short for cubic feet per minute. And we want 1 decimal place. And for the unit symbol, we want CFM. This is actually the most common unit. Now we're going to close those windows, and as you can see, 35 liters per second has been converted to 74.2 CFM.